Okay, so even if you go to the negatives, f of negative 1 is just negative 1 to the third, which is negative 1. F of negative 2 is negative 2 to the third, which is negative 8. F of negative 3 is negative 3 to the third, which is negative 27, and it just keeps on going like that. Okay, so we know whether you go into the positive or negative, every x will have exactly one y value. Okay. Now, if we apply f inverse to both sides, okay, so we know that f of 1, f inverse of 1 would equal 1, f inverse of 8 would equal 2. You're now looking at the y value, because remember, your y value is your f inverse. F of 2 equals 8. That means f inverse of 8 equals f inverse of f of 2. Now, the thing is, the inverse and the function cancel each other out. Okay, so we know that f inverse of 8 equals 2. So really, we're just going the opposite direction, using the y as our, I guess you could say, our variable term. Okay. So if you have f inverse of negative 2, not f inverse, f of negative 2 equals negative 8, then that means that f inverse of negative 8, keep forgetting that negative for some odd reason, equals f inverse of f of negative 2. Okay, so those two actually cancel each other out. So f inverse of negative 8 equals negative 2, and it just keeps on going like that because none of them will match up. Yep, so this one actually is 1 to 1. Because remember, x to the third power has kind of that shape like that. So it actually does pass the horizontal line test. Okay, so since we know each f of x and each inverse function are both unique, you don't have any that matches up to a different one, f of x equals x to the third is 1 to 1. And again, you can always show it with the horizontal line test. All right, any questions on that one? Leave that up for a few more seconds. Okay, so now we're going to look at these steps for actually finding the inverse function. Oh, anyone still writing? All right. So the first thing you want to do is replace f of x with y. That's if necessary. Okay, so they may have f of x equals some function, or they may just have it y equals some function. If it's already y, you can just leave it as y. Okay. Your second step, you're going to interchange your x and y variables. And that just means all your x's become y's and all your y's will become x's. Now your third step is now you're going to solve for y. And your last step is you're going to replace y, or that new y, with f inverse of x. Oops, clean this up really quick. Bless you.
That's x5 or?
No, x apostrophe s. Yeah. Actually, let me draw a little line through it to differentiate between my 5 and s.
So it's 5?
No, s. That's why I drew the line through it, so it wouldn't look like a
I
5.
thought you said 5.
Oh, actually. Okay, so kind of the formal definition of an inverse function. Say if some function f is 1 to 1. And you have the ordered pair xy. So f of 1 could equal something, f of 2 equals something, f of 3, so on and so on and so on. Then the inverse function of, let's say, instead of f inverse denoted by f inverse is 1 to 1 with the ordered pair yx. Okay, because remember, when you have your function, you're saying, okay, when I plug in x, I get y. When you do the inverse, you're saying, okay, when I plug in y, I get x. So you're going the opposite direction. Oops, straighten that out a little bit. Everyone's still writing. All right. Okay, so let's say, for example, determine whether each function is one-to-one. Okay. Now, if it is, find the inverse function. Of the function. Okay, so let's say first is our problem A, and we'll let that be f of x equals 4x plus 2. And for problem B, we'll find the inverse of f of x equals x to the third. Okay, so we'll start off with A. So f of x equals 4x plus 2. Remember the first step, replace y, well, f of x with y. So that gives us y equals 4x plus 2. Okay. Remember your second step, you're going to interchange your x and y values. Switch x and y. So that means all your y's become x and all your x will become y. So this y becomes an x and that x becomes y. Okay. Now your third step, remember that now we're going to solve for y. So that gives us, subtract 2. So x minus 2 equals 4y. So y equals x minus 2 over 4. Okay. And the fourth step is replace this y with f inverse of x. Okay. So this is our inverse function. Inverse function of f of x equals 4x plus 2. Now there is a shortcut when you have a linear function. As long as that linear function is not just a horizontal line like f of x equals 5 or f of x equals 8, every linear function will always be one-to-one, as long as it's not a horizontal line. So we could have looked at this one and knew it was one-to-one automatically. Okay, I'll just put that as a note on the bottom. Any linear function not equal to a constant. So like f of x equals 5 or something like that. Oh, didn't need that comma there. Will always be one-to-one. Because it will always pass the horizontal line test. put b on the side of it. Leave that up a little bit. Thought I could get that up. Come on, move out the way. There we go. Okay. Now for b, f of x equals x to the third. In your first step, you're going to replace that with y. Okay. Now your second step, you're going to switch x and y. Okay, so we have x equals y to the third. Okay. Now your third step, you're going to solve for y. Okay, so if we take the cube root of both sides, we know that the cube root of x equals y, or you can switch it around. And the fourth step, you're going to replace that with f inverse. So f inverse of x equals the cube root of x. So that's the inverse function of f of x equals x to the third. Okay, so we know the function exists, but the thing is, if you plug in any x value, you'll always get a different answer. So you know that this one's 1 to 1. Here, if you plug in any x value, you'll get one answer. So it's 1 to 1. So both of those are 1 to 1. Okay. All right, any questions on that one? All right, leave that up for a few more seconds. Anyone still writing? Looks like everyone's done. Okay, so now we're going to look at the composite of inverse functions. Okay. Now, if you have a function that's 1 to 1, for any 1 to 1, functions where you have an f and your inverse function, then we know that the composite of f and f inverse of x will equal x. And the same thing if you switch them around. The composite of f inverse and f of x will always equal x. Okay, so if we look at our previous example, we want to show whether f of x equals 4x plus 2 and f inverse of x equals x minus 2 over 4 are inverses or not. So we just previously solved for it to show that they're inverses, but we're going to say, okay, if we're just given those two, how would we verify that they're inverses of each other? Okay, so first we'll use that one. F of F inverse of X. Okay, so we know that is actually equal to F of F inverse of X, which we know would be equal to F of F inverse of X. We can replace that. F of X minus 2 over 4. Okay, so since we know that F of X is 4X plus 2, F of F inverse, that would just be 4 times X minus 2 over 4 plus 2. So we just replace the X with F inverse.
The 4 cancel each other?
Hmm?
The 4 cancel each other?
Yep, the 4's cancel out. So when those two cancel out, you're left with X minus 2 plus 2, which is just X, which we know it's true. Now we switch them around and do the same thing. Okay, so we know that F inverse of F of X, let me kind of separate that a little bit. We know that's the same as F inverse of F of X. Okay, so we know F inverse of F of X is just F inverse of your F of X, which is 4X plus 2. Okay, now since our F inverse is X minus 2 over 4, our F inverse of 4X plus 2, we just replace the X with 4X plus 2. So we have 4X plus 2 minus 2 over 4. We'll bring that up a little. Okay. So now we just go ahead and simplify. Okay, so you have 4X plus 2 minus 2 over 4, where those two cancel out. So you have 4X over 4, which is just X. Okay, so we just verified that they're both inverses of each other, because once you get the composite of each, they cancel out and you're left with just X. Okay, so that works each and every time, but only if the function is 1-to-1. Okay, any questions on that one? All right, I'll leave that up for a few seconds. All right, so let's say, oh, I'm sorry, were you still writing?
Yeah.
Oh, okay. I looked up and thought everybody had stopped writing. All right. Okay, so let's say, for example, using the table below, evaluate f of g of 3 and g of f of 3. Okay, so let's say our table looks like this. Where you have your x, your f of x, and your g of x. And your x is equal to 1, 2, 3, and 4. Your f of x is 6, 8, 2, and 1. And g of x is 3, 5, 2, and 7. Might as well restart it.